Hey guys, I was planning on how I'm doing my wall that I'm going to put my stunt wall that I'm going to put in the back of my Tahoe, and it occurred to me, of course, that what I'm doing is essentially putting together an entire car audio system. So I figured, you know what, I'm going to take my viewers on a little ride and show you guys exactly how we look through things and how we look at the details and the information to determine if the gear that we're buying is going to work well together. Because this would just as easily make a car audio system for you to be able to put into your vehicle at a pretty good price. I want to show you some different options as well. I want to show you what I'm using, but the reason I'm using what I'm using specifically is because I have this equipment. Some of these things you could get cheaper with different brands, and I'm going to explain that to you as we go. So let's get started. The first thing I want to talk about, I've already put up a video talking about this a little bit more, but this is a DSP that you can find over at Big Jeff Audio. It's $154. It gives you 6 channels in and 10 channels out. It is an excellent base piece of equipment to control everything. Every system should start with some kind of DSP. This digital signal processor has got a lot of features for the price. In fact, you're not going to be able to find this kind of price for this much feature-packed equipment anywhere. So if you decide to go this route, use my discount code CAE to save yourself some money on the purchase, but you're already getting a really good, fully featured DSP from a very well-known, well-respected manufacturer for $154. It doesn't get much better than that, guys. So let's move on. Now, the next thing that I've got already myself is 2 sets of these 6.5-inch drivers. Now, these are 8 ohm drivers, but don't let that scare you because you'll still get plenty of volume out of these with an amplifier that you normally use 4 ohm speakers for. The higher ohm load will actually aid you in controlling the speaker. That higher ohm load voice coil will have more damping factor and more control over it when you're playing. So you're going to get a cleaner sound out of these. That said, a 4 ohm speaker is going to do just fine in the control department. It's just that 8 ohms is actually a bit better. Now, looking at these, there's some things we need to know about them. First, do they fit in your car? Can you put a 6.5-inch driver where you need to go? If you can, the things you need to look for are what its power handling capacity is. And what we're interested in is this RMS number right here. This is the number that you want to try to get in the ballpark of whenever you're building your amplifier for it. Now, you don't need 200 watts to power this driver. You just need to know that you don't want to put a whole lot more than 200 watts RMS on this driver, at least not for any length of time, because it's going to substantially get hot. You're looking at the dB rating, higher sensitivity is better. And what that basically means is this number here tells you how well that driver is going to produce sound based on the amount of power you're giving it. So a higher sensitivity level is going to produce a louder volume with less power. This is the most important piece, though, for me, and that's this. This is your frequency range. This driver is designed to handle anything from 110 hertz to 5300 kilohertz. So this is pretty much the entire vocal range. And this is considered a mid-bass driver, so it can play lows pretty good. 110 is, well, it'll play a little lower than that, depending on the situation, depending on your type of mounting that you're going to do. Also, if you look down here at the resonant frequency, the FS, this is the frequency that the driver wants to vibrate at. So if you consider pushing a kid on a swing, as you push the kid, you'll notice they only want to move at a certain rate. You have to push the right speed or they just kind of jiggle. They just wiggle around and don't do anything. You got to get your speed pushed in with the same speed the kid wants to swing. And if you do those two together, then you can make them swing bigger and bigger and bigger. Well, that speed that that kid is moving in that swing is that kid's FS. Okay. Same way with the speaker. The speaker wants to move at a certain speed. And if you put power on it at that speed, it's going to really get with it, right? Well, that's the speaker's FS. And if you're playing notes that are at that FS, the speaker's going to want to do them even more than normal. Okay. So typically, you don't really want to uh, have a speaker crossed over below the FS. If you're going to put a lot of power on it anyway, you typically, the easiest way to do it is to multiply your FS times 2 and then cross your drivers over there. That's the best way to do it if you're going to put the amount of power on it that it's rated for. That's important. If you're going to put 200 watts RMS on this driver, even though it says it's good down to 110 hertz or whatever, I would set it up to somewhere around 200 hertz crossover port so that you're not playing it down into its FS rating. Now, if you're going to put 50 or 60 watts or 80 watts RMS on this driver, you can play it down even below that FS. It's not going to be able to cause any problems because the power is reduced significantly. Also, if you're going to have the driver in a sealed enclosure where it's got air trapped inside there and that air can help contain the movement of that driver, you can cross it over lower then as well, even putting more power on it because the driver is going to have extra help in controlling itself. Knowing about what the driver can do and how you need to mount it can help you understand what type of installation is best for your specific situation, what type of equipment you want to use for that situation. So now that we've discussed that, this is an important piece right here. This frequency, 5300 kilohertz. We know that we need a tweeter or something. We need to have some kind of speaker that can play down to at least this low of a frequency to handle the highs above it. And for that, we're going to go back and I'm going to show you the tweeters that we have to work with. This is the Slapz Audio Street Pro Titanium Bullet Super Tweeters. These are also 8-ohm drivers. They're 3.5 inches. They weigh 3 pounds a piece, guys. They're heavy. Keep that in mind. They're solid chunks of aluminum. They're tough, cool, wicked good sounding speakers, but they're heavy. The frequency range on these is 2.5 kilohertz to 20 kilohertz. So we know that we can play around 5 kilohertz on those mids. So these will play well below that, which means that these will absolutely cross over with those 6.5s, and we will get a good crossover coupling between the tweeter and the mid. We won't have any holes in the sound that we're hearing. It'll be all represented with a driver. That's important. Some drivers that you get may have a cutoff point, and then the tweeter may not be able to play low enough to make the difference, and you'll end up with a hole between where this speaker is able to play and where this speaker is able to play, and the music won't sound right. So you want to make sure that you can cross those over together. Those will work quite well together. Now, if we were going to add the subwoofer to this scenario, we go back over here and we look down in, and we're just going to do a basic car stereo system, for example. Let's say we went with this 8-ohm, this 8-inch Oblivion, okay? A little small Oblivion. All right, here's all of its specs. It has a 2.5-inch voice coil. It's a little 8. It's a really nice driver. It handles 800 watts RMS. Okay, that's important. We need to know how much power we need to try to put on that. But where is it? So here's its FS at 46 hertz. So that's when it's going to want to try to get with it. The QTS is important too. The QTS on this driver is 6.21 or 621. So if you were going to do an infinite baffle setup, which means you would have a subwoofer mounted on a baffle that was open to the trunk or open to the outside, or if you were going to put a subwoofer in a very large enclosure, extremely large enclosure. Having a point 0.7 ish QTS means that the driver is going to have just enough control to be able to play without that air spring behind it, but also still loose enough to be able to play higher or lower bass notes without being restricted. So a .707 is the magic number for an IB. That said, the 0.62 or 0.621 number for the QTS on this driver tells me that it's going to really like playing in a larger enclosure as long as you don't put a whole lot of power on it. If you keep the power handling well below what it's rated at, it's rated for 800 watts RMS. So if you put something like 300 or 400 watts on this and put it in a large enclosure, you would get some really deep bass out of it. But again, if you're going to put this much power on it, then you want to go with the recommended enclosure and the type of enclosure. All that's important. And at Slapz, they do have, let me see here. They do have a suggested boxes. So they're suggesting that you tune it between 33 and 37 hertz on the port. They're suggested for a sealed box is a 0.5 cubic feet, which is a really small enclosure. But it will play in a 0.5 cubic foot box sealed. That gives you a lot of opportunity to use something like this in a very tight space. So if you've got a small hatchback or truck or anything where you have very, very limited airspace, this driver would work very well in that environment. Now, if you're doing a big sealed enclosure, they're recommending 0.5 to 0.75 cubic feet. Again, pretty small enclosure. So you'll be able to put this and make use of this in a very small space with a limited amount of air volume available to you. It also has a pretty low mounting depth of only 6.6 inches. So that's not very deep. That means the box can be pretty small, and you can get down 30, 32, 33 hertz, really play the lows. This is just an example. Now I'm going to show you what I'm actually working with. Over here at Audio Dynamics page, I have two of these guys stashed away that I'm going to use in my build. And these are the AD2312 D2s. And what that means is the Audio Dynamics 2000 series 3-inch coil. Yeah, I think it's 2.5-inch voice coil. What is it? Where's that 3 come from? I can't remember. 2000 series 12 dual 2 ohm voice coils. I don't remember what that 3 is for. I'm lost on. Anyway, this is the 2000 series 12s. Is what this is. These guys have an FS of 35 hertz. We already know that means they're going to want to get busy at that frequency. They have a QTS of 0.5, and that lower QTS means they're going to play lows pretty good. Now that at 0.5, around 0.4 to 0.5 QTS, usually you're going to be putting, well, anything from about a 0.35 up to a 0.5, you're going to want to put that in a ported enclosure, typically. It's not going to be recommended for a sealed enclosure at all. But that said, you can use one in a sealed enclosure. Just understand that you want to reduce the power whenever you're operating a subwoofer in an enclosure size or an enclosure type that it was not intended for. You're going to want to reduce the amount of power that you're giving it. You also may need to electronically control that subwoofer. For example, if you're operating a subwoofer in an enclosure that's much larger than what it's recommended, you may need to use a high-pass filter or a subsonic filter on the DSP or the amplifier to reduce the low frequencies that you're sending to that sub, because it may not have enough control to keep itself from becoming mechanically damaged by trying to play too low in the enclosure that you put it in. So if you're going to operate outside of the manufacturer's recommended enclosure type or size, you're also going to have to factor in power reduction and or electronic control over the subwoofer's movement to accommodate that different size or different type of enclosure. Um, if you've got that factored in, you can absolutely do those things. Now, going back over here, I'll cover a couple of things that are interesting. For example, the QMS is the mechanical Q. That's the physical characteristic of its Q factor, which is the Q factor on a sub is kind of complicated. It goes for any speaker, not just a subwoofer. But the Q factor is kind of like a bell. Think of it as a bell. Um, it's sort of like the FS, but it's more like the characteristics that represent why the FS is what it is. FS is a frequency that it is tuned to swing. Okay. The Q is how easy it is to swing. The mechanical Q is the mechanical resistance to it moving. Okay, so it's got components in that driver that resist it moving. The spider pack, the surround, all these things can provide resistance to it moving. So that is the QMS. The QES is the electrical resistance. So right here, whenever the speaker's playing, it has this QES, and the QES is the electrical resistance to the speaker moving. So it's like, and when you take those two, the QMS and the QES, and put them together, you get the QTS. The QTS is all of the speaker's characteristics that resist it from moving back and forth. And I'm trying to make this as simple as I can. And then there is the final Q, which is, what is it called? The QMS? No, the QTC. I had to think about it. Now, it's not listed here, but whenever you take this driver and put it in an enclosure of any type, you end up with a QTC. And the QTC is the combination of the QTS and the enclosure that you put it into. And depending on how big, a larger enclosure is going to have a lower QTC. A smaller enclosure with more restricted air movement is going to have a higher QTC. But you ultimately, and to design a really good setup, you ultimately want your QTC to be around 0.7. That's where you want to end up at. And any type of any type of enclosure that you put a speaker in is always going to raise the QTC. Okay, so the QTS is always going to be the lowest point when you put that speaker in any enclosure, an infinite baffle, just a baffle and nothing behind it, just mounted in a hole in a board, you're always going to raise that Q. It's always going to come up some just from being mounted in a baffle. But the more restricted, the tighter the airspace and the smaller the enclosure you have, the more you're going to raise the Q factor in the end. I'm going way off topic with this, but I feel like it's always a good time to learn things. And I'm doing the best I can to give you general knowledge that you can eat without having to have a degree in sound engineering to pick up on. Back to the discussion. So, you know what application you're going to put the subwoofer in. In my particular situation, I'm going to be mounting subwoofers in a little wall. So I'm going to create a stunt wall, and my subwoofers are going to be asked to play higher notes than normal for a subwoofer. I'm going to be having them play 150 hertz or higher. So that's a thing. Can the subwoofer do that? A lightweight subwoofer with a fairly low Q and a high FS will do that better. But you have to understand that they weren't designed to play that frequency. They were designed to play up around 60 to 80 hertz, maybe a little higher. So I'm going to be asking this subwoofer to play higher than its recommended frequency range. I'm also probably going to be putting it in a sealed enclosure, an oversized sealed enclosure, and I'm not going to be putting very much power on it. So I'll probably be putting, 100, 120 watts a piece on these things, where they are designed to operate with 500 or 600 watts a piece. So all of these things combined together change completely how this subwoofer is going to operate. And I have to understand, using the stuff that I have, the tools that I have, and the details and the QT and the Q factor and the FS and all of these tilt small perimeters help me to understand whether this specific driver will work well in my specific use case. It's not about what brand is best or what's no, man, that's irrelevant. Does the driver's specs match the scenario that you're trying to put it in? That's the question. Typically, smaller drivers will be able to play higher notes a little bit better than larger drivers, but that doesn't mean that that's the case all the time. It's just a good general go-to thing. Less moving mass is easier to move at a higher frequency. So a cone that's smaller and pushing less air in front of it is just going to be a little bit easier for that cone to be able to do that at a faster rate than a large cone pushing a lot of air. It's going to take a lot more power for that to be able to play those higher notes because it's just more work to do. So by default, a smaller cone will usually play the higher notes a little easier, which is why tweeters are usually pretty small, among other reasons. That said, I'm going to have these drivers operating outside of their perimeter, but well under their power rating. And I think they're going to do a good job. This is the part where we're just guessing, because there's no information hardly ever on how to operate something outside of its intended perimeters. You've got to use what you have and go for what you know and hope for the best. Honestly, that's what I'm going to be doing. But if you guys are interested in picking up some kits like this and you want to get into this, I would suggest going this route, going over here and picking this guy up. And if you use my discount code CAE at Slapz Audio, you get 10% off of whatever you buy. And that's a real good price on a beefy little 8-inch driver. And I've already showed you some nice little mids and highs. And the amplifier that I'm planning on using for this setup is this guy. Pull up the wrong thing there. There we go. This is a little 160.4. So this little amp does 160 watts per channel. It has 4 channels, and it's $109. And this is what I'm going to be powering everything with. So, like I said, head over to Slapz Audio, discount code CAE, pick up the gear that you need. Go over to Big Jeff, pick up that B2 610 DSP for $154. Use my discount code CAE there. Knock 10% off of that. I think it's 10%. It's a savings. I don't remember what it is for sure, but it still saves money, and money is good. So save the money. You can't go wrong with this setup, guys. So hopefully you learned a little something today, and the information I'm giving you is correct enough. But know that there's more to be learned. It's not perfect. I just broke it down in the simplest way I could so that I can communicate the basics to you guys. If you found it interesting, be sure to dig deeper on the internet, learn more about it. Head over to PS Sound. That guy is brilliant. Of course, you need to have your stuff, be ready to absorb a lot because the information gets crazy. I gave you the basics, but only in bite-sized chunks. If you guys found this helpful, be sure and hit that subscribe button down below. Tune in to my live show on Sunday night at 7 and Friday night at 9 Central. And you can ask questions and we'll answer them the best we can. For now, guys, slam the like button and peace.